So now that the map is done, I'd like to welcome you to the session, OTS Connect session, Engineering the E in STEM with Dave Doucette and Lisa Lynn Cole. It's nice that we have so many people from all over the province joining us for this session tonight, and we welcome all of you. I'd just ask Dave and Lisa if they're ready to do their introduction. And I'll turn it over to them. Okay, there you go.
Let us just activate our video. So if you have video reception right now on your computer, or I'm not sure if you have it on a pad or a phone if you're using it, but you should be able to see Lisa and I. So we're just going to give you a face to look at right now, and then we're going to turn it off because it does use a lot of bandwidth. But hello from Dave. And
hi from Lisa.
So that's what we look like. So now we're going to just turn off the video, and you will be back to audio. So Lisa, if you introduce yourself first.
Sure. So I'm Lisa Lynn Cole. I am now the past president of the Ontario Association of Physics Teachers. My daily job is I'm a science and technology program facilitator, or some people will refer to me as a consultant for the Durham District School Board. And I was once a science department head, mostly a physics teacher at Uxbridge Secondary.
I'm Dave Doucette. I'm a former president of the OAPT, Ontario Association of Physics Teachers, 2009-2011. I was 25 years in the classroom as a science teacher, chemistry and physics and general science. And Lisa and I have been working together on the OAPT for close to a decade now, and probably in the last 5 years in particular, focusing on STEM and the initiative and how OAPT can help support STEM across Ontario. That's kind of what brings us here. So what we'd like to do at this point, just for two reasons. One is to get to know you a little bit better, but also to get you using some of the interactive features that we have in this webinar. So the way that we'll do it here is we'll go through it question by question. You'll use your poll feature, which was explained to you just a couple of minutes ago, and then the polls will be collected and then we'll take a look at them. So if we could start with question 1, where you teach mostly in the following grades. If you move to your 4th icon, that will give you the choices, and once those choices are available, A to E, just make a selection. Once we have that data collected, then Mally will display it. So we'll take about 15 seconds or so just to do that. So this is a first for us as well, trying out these features in this fashion. So we'll get better at it as we go along. So on your 4th icon, you'll see a choice, A, B, C, D, and E. So select the appropriate one for question 1. We didn't have an option. I see in the chat box, I teach all grades. How about just select maybe the grades that you've taught most frequently in. The option, teacher candidate at the York University. Where would you like to teach? What would, ideally then, what would be the grade range that you would prefer to teach? Again, it's just to get us some overall general data. And I think, oh, Laura's away, so.
It looks like we have a great distribution of grades being taught, so this is going to make a very interesting webinar in terms of the discussions we're hoping to generate today.
So Monica 2, try the poll on the far right-hand side. If you click on that, you should get the choices. And Shaquila, is there a choice that fits you reasonably well? Okay, I think we'll call that. We're still just getting used to the features, obviously. But if you wanted to display this, Mally, there, for example, is how this looks when we display the results. So we'll just go ahead now and go to question 2. So how long have you been teaching? And once again, use the 4th icon. Just pull on that, and there'll be, again, the choices of A, B, C, D, or E. Choose the one that's most appropriate.
So Dave and I are going to select greater than 10 years, although Dave might choose E.
Yeah, we're on the boat together. And once again, it's the 4th icon on your left-hand side, just below participants. And where you see your name directly below that. So the 4th from the left, it gives you the choices. Okay, looks
like
coming in better now, getting more used to it. So it gets you familiar with the features that we have to offer, the interactivity features for Collaborate, Blackboard Collaborate. Okay. So why don't we just display this as well, and we'll, Mally, and then again we'll move to the 3rd question. So the 3rd question, once again, is a multiple choice question. It's moved to the 4th icon, and you'll have a choice of A, B, C, D, or E, your preferred teaching area. So it looks like, just looking at question 2, it looks like probably about an average of 3 to 5 years. Kelly, we get it. Yeah, it shows because yours is a mix. Understandable.
Perfect.
But this is really just preferred teaching area. So if you do have one, that would be in your ideal teaching situation, because that may not, of course, be the case. But it just gives us an idea of the background of all of you, and that helps us as we go forward and strategize.
Okay.
Okay, Mally, I think that'd be good. Science, math, and other. Excellent.
Perfect. So we'll move on to the next slide. We only have a few more questions to ask.
So question 4, really, we were interested, what kind of technology are you using in the classroom? So your choices, of course, a computer with data projector, computer with data collection devices, tablets, apps, and data collection devices, or a variety of technologies depending on the instruction, or in some cases, it may be almost none. So once again, just make a choice of the icon on the far right-hand side. Perfect. Okay, I think we can probably display that as well, Mally, please. Mostly a variety of technology. That's kind of what Lisa and I were expecting. Now, question 5 is simply a thumbs up or thumbs down. So that'll be the first icon, not the 4th icon. So if you look at the first icon and click on that, you'll see a variety of choices. And thumbs up would be you have access to a microphone, and thumbs down would be that you do not. So what we did find was when teachers were in the schools, often, especially in the secondary level, they would have a computer availability, but without a microphone. So typically when you're at home, particularly on a laptop or your home computer, it's more likely that you'd have availability to a microphone. So thumbs up. This is the first icon on the left, just below participants where your name is. Thumbs up for yes to a microphone, thumbs down to no. And once again, get you familiar also with some of the interactive features of Blackboard Collaborate, which is the learning management system that we're using for this webinar. Okay, so we'll go to question 6. Just the acronym STEM, Science, Technology, Engineering, and Mathematics. Just a general question, how familiar are you with STEM, with 0 being minimal familiarity and 5 being highly familiar? So I think for this we would just type the number in the chat box, just a number from 1 to 5. 3, 4. Oh, very good. And 1, 1. And that's quite an improvement, I would say. Even 3 years ago, when Lisa and I would ask this question, typically the answer would be 1 to 2.
Yeah.
With
sometimes 0.
Sometimes 0. So clearly, the message and importance of STEM is getting out. Okay. Last question. So there's 3 questions we just put there. Just select one of them for a quick comment. The biggest hope or challenge for the growth of STEM education is something. What you hope to gain from this webinar, or if you were a Minister of Education for a day, what would you do? So just choose one of these 3 and just type a comment into the chat room. And again, that way we've been through several of the features now, and you'll be familiar with them. I guess to make it easier, we could have sub-numbered them as A, B, and C. For A, my biggest hope, B for what I hope to gain, and C for if I was Minister of Education, to save you having to type anything like that in. Interesting.
Well, I'm quite excited at the statements, because I think we're going to be able to generate some great discussion this evening on some of those statements, and hopefully some of the ideas that we've planned for you today will come in handy in your classroom.
Okay. So we've brought you to the next slide. So basically, what is the focus and the purpose of this particular webinar? So there's 2 things that we want to address. First, you seem quite familiar, and we were surprised with it, that we have a level of 4 out of potentially 5, almost on average, of your understanding and familiarity with STEM. So we'll quickly go through some of the data just to so that we're all on the same page with respect to what we consider to be the significance. And then what we want to look at is the question of how do we support engineering and STEM when engineering itself is not in the K-12 curriculum. So those are our 2 focus points today. And primarily, Lisa will be conducting most of this. She'll be the lead presenter. She's most familiar with it, but also we found for webinars, if I monitor the chat, etc., and she keeps her eyes on the webinar itself, it's the most effective way to do that. So I'm going to bring Lisa in at this point to take the lead on this.
Perfect. So the first thing I'd like to do is just sort of frame why we're actually even running this session, because technically Ontario Association of Physics Teachers oftentimes we're not considered a group or an organization that would run something that's K-12. And so this is something a little bit new for us in that we're trying to message or work with teachers that are in our elementary schools as well. So just to frame why STEM, if we look at Let's Talk Science is a national organization, and I don't know if many of you are familiar with Let's Talk Science. So if you are familiar with Let's Talk Science, can you give us a thumbs up? And if you're not, a thumbs down, just so that we get a sense for whether or not you're familiar with them. If you are not familiar with them, they are a national Canadian organization that offers a lot of outreach as well as free resources for science teachers across Canada. But part of the organization also works to conduct research that provides a Canadian perspective on science education, and recently they started to focus on STEM education in Canada. So much of the data that exists currently tend to be American or from the UK or from Australia, and very little is actually available in Canadian data other than the ones that Let's Talk Science provides. So if you actually go to Let's Talk Science's website, and I have included a link there if you're interested, you can actually find some of their research documents where they've conducted surveys nationally to understand student perspectives, parental perspectives, as well as teacher perspectives on STEM. So we know that Canada spends a lot of money on K-12 education, and some of us may argue that they don't spend enough because we don't have enough technologies in our classroom, etc. But we do spend quite a bit of money on K-12 education, and yet we have very few students pursuing STEM career pathways. And in fact, if you look at our curriculum in high schools right now, mathematics is only required till grade 11, and science is only required till grade 10. And yet, when we look at career pathways and opportunities for our students, without a grade 12 math and or science course, doors close to half of university and college pathways. And so this is a growing concern, because we know that much of our opportunities for our students are in the STEM fields, and yet students are not pursuing them. When Let's Talk Science approached students about their perceptions on science in particular, 72% think that science is fun, and there's a growing appreciation for science. Popularity we see in shows like Big Bang Theory and watching documentaries on black holes has increased over the years, so there is much interest in science and STEM. However, if you ask them if they're interested in working in science-related jobs, only 12% are actually indicating interest in pursuing science beyond just everyday sort of appreciation of science. So it makes you kind of wonder in terms of what our role is as educators in sort of fostering their curiosity. And also, if you look at the Canadian job markets, I know this data, this information is from 2013, so it's already old. And I imagine it changes quite rapidly. But 70% of top jobs in Canada require a STEM education. So remember, we said that if they don't take grade 12 math or science, 50% of career pathways close, and yet 70% of our jobs in Canada require a STEM education. And if you look at STEM workers, they earn an average of 26% more and are less likely to experience job loss, especially when there are concerns about economic growth in a country. So, which makes an interesting, compelling argument for why STEM education is important and how we might support that as educators. We also took a look at some Ontario high school data. This is from 2009, so we recognize that it is a little older. It was data that was gathered through ONWE. ONWE is the Ontario Women in Engineering. It's actually a partnership amongst many faculties of engineering across Ontario. And so they actually requested some data from the Ministry of Education in 2009 to take a look at girls and what percentage of girls are actually pursuing courses that lead into engineering pathways. So if you look at grade 10 math and grade 10 science, you see about 51% and 52% are girls, which makes sense because everyone needs to take grade 10 math and grade 10 science. If you look at grade 11 math, you'll also see that it's approximately 50%, at 47% there, because grade 11 math is required. But you'll see that grade 11 physics starts to decline, and then more so into grade 12 physics. And if you look at mathematics, you'll see that depending on whether it's advanced functions or calculus and vectors, there will be some differences there. But the most alarming difference would be in physics. And the reason why we're using physics as a marker is because all engineering programs in post-secondary programs require a physics credit currently. So if you have any questions at any time, please feel free to raise your hand if you'd like to speak or put questions into the comment box, because I know that I'm sort of going through the data pretty quickly because I want to get to the activities, but I think it's really important to look at what is the current status of engineering or current status of STEM in Canada. So again, ONWE also extracted this data, which shows data over time. And what it's indicating in the gray bar graph is the gray parts is the total number of engineering students that are enrolled in Canada over time. And so you'll see that over the years, the number of engineering enrollment, they have increased substantially. In fact, faculties of engineering have been increasing their enrollment because there is a growing need for engineers in Canada. And yet, if you look at the pink bars, which is an indication of how many girls or how many women are entering going into engineering, proportionately, we're sort of oscillating around 20%. So even though the number of enrollment in engineers have increased, the proportion of women going into engineering has not been increasing at all. If anything, it's been pretty steady, and sometimes, in fact, it's been going down. So in a more picture-friendly sort of version, if you consider that there are 10 academic science students or that are girls and 10 that are boys, you'll see that the attrition in terms of the physics courses over time. So at the end in grade 12 physics, you'll have 1.5 girls versus 3 boys. So that's our 33%. And of the 33% that take grade 12 physics, only a fraction of them is actually pursuing an engineering degree. So in my role at the Durham District School Board, we have been working on developing a STEM initiative to support classroom teachers K-12. I am a program facilitator that supports science and technology, or now STEM, from kindergarten to grade 12. So the challenge here is to see what kind of data do we currently have. And when we looked at our 2015-2016 data, so I'm sharing with you what proportions of our grade 11 and 12 students are actually taking a STEM course. So I've listed all the what I would call STEM courses in our board, and this is basically what our benchmark looks like. So if you look at a course, program like mathematics for grade 11 and 12, we have 79% of our grade 11 and 12 students taking at least 1 credit in math, and that's clearly because grade 11 is required. If you look at the other disciplines, you'll see a substantial decrease. Biology, which is, we consider it to be one of the sciences that most students are interested in, we'll see that we only really have 34.7% of our students even pursuing biology, which surprised me because I really thought that there would be more interest in that. So overall, our students, in terms of, for the purposes of engineering, if we look at physics, we only had 21% of our grade 11 and 12 students taking 1 credit in physics. So that's a very small proportion of our senior graduating, our senior classes, even having an opportunity to pursue engineering even if they wanted to.
I'm just going to jump in just for a moment, just to put a different spin in the sense on this data. This data is not fixed in the sense that you can change data. So I would refer to, for example, the U.S. have been following STEM education now for well over a decade, and they identified physics as one of the problematic courses just in terms of getting students into engineering. So they put a lot of money and effort and time into trying to change the data patterns that they saw. So they had very similar data patterns to what Lisa's just been showing you, and over the last 10 years, they've gone from about roughly 17 to 19% of the students in high school taking a single course of physics, which in our case would be grade 11 or 12, and in jurisdictions now, on average, it's around 50 to 51%. And it's as high as 70 or 75% in some of the states that have really pursued aggressively a STEM education format. So just as a background to what Lisa's saying, these numbers, although they're a little discouraging in a sense to us, they are changeable, but it takes a systemic desire to want to do so. And hence, again, the purposing for a webinar such as this, bring it to our attention that this is the data that we currently have, and it is changeable. But we do have to have a collective will to want to do this. Go ahead, Lisa.
And I just saw a few statements along the side. It is true that some of our schools don't offer the courses every year, which is quite scary. And in fact, if they're not offering it that year, it would just go down as a zero in terms of availability of students taking the course. And in terms of including applied and academic subjects, they are all included because I did not eliminate any STEM career pathway. Because when we think of STEM, we're not just thinking engineering, right? We're also thinking of all of the technical programs as well as apprenticeship programs, etc. So what I didn't include here is that when we do look at certain pathways, there is an alarming disparity or difference between girls and boys, especially in our college level physics program, which leads to many apprenticeship programs. I think in the 2015-2016 school year, when I looked, we had a total of 25 girls taking college physics board-wide, which is the reason why Ontario Youth Apprenticeship Program is concerned about girls in apprenticeship programs. So we have a lot of work to do in terms of figuring out how we might actually engage our students in a way to shift their thinking as well as to shift where students might be considering to go over time. And by taking a look at this data, the data was never intended to be looked upon as it's a problem of just high schools, right? In how STEM is being planned for our board, we're really looking at how do we scaffold a system in which we can build programming from kindergarten to grade 12 so that all students have accessibility to learn in a way that will provide opportunity in STEM, potentially, knowing that not every student is going to be interested in STEM. So it really isn't about, converting everybody into engineers. It's really about our students choosing to pursue STEM because they are wanting to pursue it, or are they choosing STEM choices or are they not choosing STEM choices because they just never had an opportunity to explore it? So it's about providing opportunity.
And it's closing that link that Lisa pointed out from Let's Talk Science. As we've been very successful through the focus on inquiry education in Ontario over the last several years of making a STEM-based kind of education interesting and relevant to the students, where we surprisingly were not able to make much ground or any ground at all really was getting to choose it as a pathway. So in a sense, we're halfway there. We're doing it well in the classroom, but somehow we didn't make that explicit link that there are career pathways in this as well. So, science and technology and mathematics isn't just interesting and relevant, but it's a clear pathway. So it's just closing that particular gap. So that was surprising data when Let's Talk Science collected it. We knew we were doing well in the classroom.
So we're now going to take a look at engineering and STEM in particular, especially when it's not explicitly in our K-12 curriculum. So what we'd like to do first is take a look at what the engineering design process looks like. So the Society of Automotive Engineers has a program called A World in Motion. Maybe if you can put a thumbs up if you're familiar with the program and a thumbs down if you're not. And so the Society of Automotive Engineers is an American organization. They have a foundation that's a charitable arm of their professional sort of line. FAE is most I think, most famous for their motor oil, if I remember correctly. And however, so they're American, but they do have a series of educational kits or activities that they package together, and it's sponsored with a few companies that have helped to develop them. And so in their resource package for teachers and educators, they outline an engineering design process as the one that's listed here. So setting goals, building knowledge, design, build and test, finalize the model, and present. And there's a series of iteration processes built in between, but we wanted to simplify it for the purposes of this graphic. And if you take a look at this engineering design process, oops, I just want to go back for a minute. If you take a look at this engineering design process, and we think about our science curriculum in particular, right, and the inquiry model, what I'd like to do is evaluate how the engineering design process might align with our inquiry model, because I think that's the only way we're going to make a compelling case for doing the engineering design process in our classrooms. So just so that we remember what the inquiry process in the Ontario curriculum says, right? So there are actually 4 steps to the inquiry process as outlined in our document. There's the initiating and planning, performing and recording, analyzing and interpreting, and communicating. And what we would like to do is, how do these 2 things compare? So we're going to actually do a collaborative whiteboarding exercise where we provide you with an opportunity to sort of brainstorm and work together to see how each of these 4 stages in inquiry align to this engineering design process. So for the initiating and planning section, what we would like for you to do is actually use the tools along the side with the text. So the whiteboarding tools with the text to actually write in some comments underneath each category. So what parts of the engineering design process would fit into initiating and planning? And then the second statement, a way to reinforce
the students the link between engineering design and initiating and planning would be. So yeah, just the tools are on the left-hand side of your whiteboard. You can see them. At the top is a text tool, etc. So we invite you at this point just to add, particularly textual material as well. If you did want to speak to this, just, I guess, put a hand up.
Yeah.
The hand up, yeah, that would be good. And then we could activate your microphone.
Want to see the other? Okay, so if I flip to the other page, I apologize. I guess we should have, I wish there was a way to put the window off to the side.
So what fits into initiate and plan? What part of the engineering design process? That's the first part of the question.
Is it okay if I switch back? So if you can use the text tool on the whiteboard tools, so one with the letter A and the lines. So I can do an example. I'll just put.
We're doing that.
Okay, perfect.
Perfect. Initiating and planning, asking good questions, that's setting goals, building the knowledge as part of the planning. Designing. So it just reinforces the engineering design process is not something new. It's very nicely related or correlated to the inquiry process. In fact, you're already doing it. If you're doing inquiry, you're indirectly teaching the engineering design process. Building on domain knowledge, absolutely. Mm-hmm. Just so you'll see from our end, when you're typing in the text boxes, we don't know actually who's contributing. Mally may be able to, I'm not sure if she can, but we don't. So if we do, we would actually comment just with respect to your first names, or just doing so because we're not available to see that. Case studies.
Dave, you can see it if you just click on the text box. And right click, you'll be able to see it says created by whoever. So maybe a suggestion for if you're typing in the chat box, if you want to put your name at the top, and then Dave and Lisa can just address you and make comments.
Yes, thank you. That's a good idea. With Mac, we don't have that function. I don't think you may have it with the PC. So yeah, just
okay. So just double two-finger click on the box, and it'll say who it's created by.
Yeah, we see it.
Oh yes, we do have that. Excellent. Thank you. So, Niels, you've come up with a very nice suggestion there, using case studies of existing things that have happened to show if people have looked at issues, problems, and designed solutions. And if you all have heard of the term JUGAD, J-U-G-A-A-D, and that's innovation, sort of worldwide solutions, cheap solutions to problems, locally based solutions, that is kind of moving across much of the world now. And there's a good example where you could pull up case studies of how you can solve local problems very efficiently with very little capital investment required at the local level. So that's JUGAD, innovative. It's innovative. I'm just trying to think of the name of it. JUGAD, J-U-G-A-A-D, and it's just one of the local forms of innovation for this. But lots of examples that you could pull out that would be case studies, just as Niels has suggested. Mm-hmm.
All right.
Frugal innovation. That's what JUGAD means, frugal innovation. So basically, cheap, affordable innovation.
All right. So it looks like we have some great ideas about how engineering design process fits into initiating and planning. So what I'd like to do is move on to the next stage in our inquiry process. So if we go back, I'm going to temporarily go back to this image again. Right, and so we're going to actually look at perform and record, and what portions of this engineering design process would fit into the perform and record portion of our inquiry process. So just focusing in on the performing and recording portion, what parts of that engineering design process might fit into that? So do you want to I'll take you back to the image for a few minutes. Just for a few seconds there, just so that you get a sense for what the engineering design process includes. So what would align with the perform and record? And how might you reinforce those portions of the engineering design process with your students in your classroom? So if you could use the text tool again.
Mm-hmm.
Mm-hmm. Definitely build and test. the iteration process is really critical in the engineering design process, absolutely. And those of you who are in the primary and junior divisions who might be afraid of the word engineering, it is okay to actually just refer to the process as the design process. In fact, I've been a part of a group of professionals in the engineering field participating in an engineering change lab. And even within the engineering profession, they basically preferred it to just be called the design process and not to really focus in on the engineering part, which I find interesting, because you would think that they'd want the word engineering in front of it. So definitely don't be afraid of the design process because of the word engineering. It is essentially the design process. What I do find interesting about the performing and recording portion of this is that really there is a way of connecting the engineering design process, and especially the performing and recording portion, from the science curriculum to the math curriculum. And there are many opportunities where many of the engineering design sort of activities allows for some rich discussions on independent, dependent variables, controlled variables, designing experiments to collect real data and authentic data that can actually be used to explore mathematics. So I think this section here, in terms of the performing and recording section, actually provides great opportunities to link science and mathematics together. And I know that when I'm running workshops with teachers, that is something that I'm focused in on in terms of exploring STEM sessions, where we're explicitly looking at how do we connect science curriculum to mathematics curriculum.
Okay.
So this looks great.
Good input. Thank you, folks.
And I'm just being cognizant of time, so I want to make sure that we get a chance to also explore some resources. But so I'm not sure if we're going to actually continue with doing all of the brainstorming here. But what I'd like to do is actually go back to the graphic that compares the two, and I'm hoping that you're getting a sense that the engineering design process is actually embedded inside of the inquiry process. So we looked at initiating and planning, so you included statements such as developing questions, creating a plan for design, and some different strategies in instruction, including problem-based learning, and connecting it to the community and the world. And then when we look at the performing and recording, what you've mentioned is this iterative process of designing and testing, collecting data, recording of trials, brainstorming, and I love the suggestion of portfolios and documenting their experience through notebooks, videos, etc. So if we go back to the graphic again, you can see that the analyze and interpret, and one of the comments actually alluded to the design and test part also being a part of the analyze and interpret portion of the inquiry process. That there are moments in the engineering design process that very explicitly align to the inquiry process. So I don't think it's a stretch for us to say that we can teach the engineering design process inside of our inquiry process. In addition to that, I would argue that the front matter of our Ontario curriculum, which speaks to the technological problem-solving section of our curriculum in science, aligns also very nicely with the engineering design process. If you have any questions or comments, feel free to step in. Now, from the work that I've been doing with the Durham District School Board, what we did was we came up with a graphic that sort of talks to a STEM process, where the engineering design process is a layer on top of the inquiry process. And I apologize that the graphic isn't as clear on screen. But you'll notice in the table along the bottom that I've indicated the initiating and planning, performing and recording, analyzing, interpreting, and communicating. And within the inquiry process for science, I've put in sort of the scientific method that exists in those subcategories according to our curriculum. And what I did was I did a similar task to what you were starting to do, where I aligned the 4 stages of inquiry, or the 4 components of inquiry in our curriculum, to the engineering design process. So you'll see that I did a very similar mapping exercise as the group here did with the first 2 stages.
A question, Lisa, is can the graphic be made available in higher res? Not in this particular slide, but we can make it available otherwise.
Yes, we can definitely make that available. In fact, we are only focused on the E, the engineering today, but the graphic actually has innovation and creativity sphere on the outside. So the outer gray that's in the graphic there is also included to address creativity and innovation. I know that many will argue that STEM should be STEAM with A for arts, and our board decided to keep it STEM, but the A is being addressed in the creativity and innovation portion of our STEM process.
And would we be able to provide this as a download?
I could probably grab the image for you, and then we can maybe share it through Mally, if that's okay.
Okay.
We just ask that the graphic, if you are planning to use it, is intact with the Durham District School Board logo. That's all. So for this portion of the webinar, we're going to take a look at 3 sort of engineering experiences in the 3 different divisions there. I included the junior and intermediate division and together, actually, just for simplicity's sake. But we were going to have breakout rooms for these. But I think because we have a smaller group, we're going to just do it all in sequence. But I also think it's important to do it all in sequence, because when I work with teachers, I recognize that sometimes when we isolate the primary division from the junior, intermediate, and high school, then what's happening in primary is sort of done in a bubble, and we don't really know what's happening. Whereas if we all open up our dialogue between our divisions, we get smoother transitions. So I think it's sort of valuable for us to sort of work together on this. So the first one is a K-3 Engineering Through Literacy. It's Experiential Learning. And this resource was actually something that I worked with a teacher librarian actually on. And so if you go to the link there, and I think Melly will put the link in the chat box, so you could actually click on the link and your browser should open up. A SMORE is actually an interactive newsletter. You could actually create a newsletter that embeds videos and things in it, and you'll see that the first item at the link in this SMORE is actually the most magnificent thing, this book, and there's a little video underneath, so feel free to explore the video. But the focus question here will be, how might you use this resource to get students to plan, build, test, and build again in your classroom? So take a look at the link in the video and think about how you might use this in your own classroom to plan and make a case for why you might use a piece of literature to sort of inspire an engineering experience.
How long would you want to set the timer for, Lisa?
Maybe 2 minutes. Is that all right?
So we really just want people to skim and scan this, not take a great deal of time, just to get some ideas and some quick brainstorming on the focus question. How might you use these resources to get students to plan, build, test, and build again in your classroom? So really just a quick brainstorming, and obviously once the webinar is over, you can take a little bit more time and look through the resource. So just being cognizant of time.
Exactly, and we want to make sure we get to the other resources as well. And so I have put up a slide where you could use the text tool again to just sort of list sort of your thoughts on how you might do that in a primary classroom.
And of course, anyone can contribute. So you see the timer at the top of your the blackboard, of the whiteboard, and the link is in the chat box to the most magnificent thing. That was a quick 2 minutes. Well, actually, we set a timer as kind of inadvertent, the 2 minutes. But if you want to move on, we have about 10 minutes or so left. Just give us a quick thumbs up, or actually a thumbs down if you need a little bit more time.
Actually, Dave, you have until 9 o'clock.
Oh, do we?
Yeah.
Okay. I thought we were aiming for 8:30. That's good. We have to push this too fast then.
Perfect.
Perfect.
So we'll give you some more time to come up with some ideas. And feel free to explore some of the other resources on this more, because there are multiple books listed there, all with an engineering theme. Mm-hmm. Yeah, absolutely. I definitely like how it explores frustration, perseverance.
And a great opportunity to leverage in the character traits.
Mm-hmm.
And the learning skills.
The growth mindset, absolutely.
Mm-hmm. Great suggestions. Thank you for your comments. So just looking at the first comment, refer back to the story when students start or in the middle or at the end of a project. So it'll be like a touchstone to keep going back to.
That's a great idea.
That's a great idea. That's actually teaching contextualization, which is a fairly advanced thinking skill, but one that we, in terms of the growth mindset that we want to promote. And by doing that explicitly, you help develop literally the dendritic connections for different parts of the brain to talk to one another. That doesn't happen by itself. It needs to be very deliberate. So thank you for that suggestion. It's very good.
I also like Gloria's comment in the chat section. Great book for encouraging students to take risks. #makerspace. Because I know that I've had lots of schools interested in creating makerspaces in their schools. And in fact, a lot of teacher librarians really rethinking what the library space could include to support STEM education. So thanks for the reminder of makerspaces. I think we're going to see a lot more makerspaces popping up in our schools.
Actually, outside the schools as well, it's happening within the communities. It's engaging older learners and bringing them back to the classroom.
Mm-hmm.
So the idea of the lifelong learner is embedded in the makerspace. Actually, very exciting possibilities, very exciting issues that are going on with respect to makerspace.
Mm-hmm. So if everyone's okay with it, I'd like to move on to the next one. Are there any questions or additional comments you'd like to share? All right, so let's move on to the next one. So the next one we have is dealing with flying objects. We're physics teachers, right? So we're a physics organization, so we thought, we always have to have things that are flying. So there's a few resources or links listed there. So feel free to sort of explore some of those. And the focus question for this one is, how might you use these or other resources to get students to plan, build, test, and build again in your classroom? So the same focus question, but this time focused on flying objects for grade 4 to 8.
And the focus, of course, on inquiry and really almost the smarter science methodology of hypothesis testing, etc. So these are the links are again in the chat box. So we'll just move to the next line so that, once again, you can add comments. And I think, Melanie, this time we'll maybe go for a 5-minute timer. Thank you. So the timer's at the top of the page. That should be a good amount of time. Just reading Melissa's chat comment here. Melissa, when you did the paper helicopters, did you do it as a hypothesis testing type of inquiry? Okay, Melissa, you should be.
There you go. What I remember that we did is that she asked us to use the assigned instructions based on the Exploratorium, and then we were able to test with the partner, which is the different type of how high we have to go, how has to have a certain accuracy level, and then she allowed us to test it through a different design. Like we would make a different airplane and see if the design would fit the accuracy that we had before.
Okay, and I assume then that they're anticipating that their changes would either increase the time or decrease the time? Was that like a hypothesis in that case?
Yeah, something along those lines.
How did they like it?
I enjoyed it. Everybody else was, all the teachers were having a good time using this project.
Yeah, it's very hands-on, minds-on, isn't it?
That's correct.
Thank you. So we have 90 seconds remaining. just looking at, we track results in an Excel spreadsheet. What grade? Oh, grade 6 flight, excellent.
Mm-hmm.
A perfect link to mathematics, isn't it?
And in terms of helicopters, absolutely. Like, why not extend it into current technologies?
Mm-hmm.
Especially nowadays with the remote-controlled flying devices that students like.
So 5 minutes to.
Yeah. So some great connections to grade 6 flight, and I'm going to actually extend it a little bit further than that, because I always like to have us thinking a little bit more in terms of how it might connect to math. If you look at the first link, I did include a resource from Society of Automotive Engineers. Now, there is a cost to these kits, but don't let the costs fool you, because there are ways of connecting with SAE Foundation so that if you obtain training through their free training program, that you could actually receive these kits for your classroom at no cost. So what SAE Foundation does is actually finds local corporate sponsors to sponsor your classroom so that your classroom could get the kit for free. So don't let the cost of the kits scare you. And in fact, if you connect with me via email, I can connect you with the person from SAE Foundation that can help do that for you. So if you take a look at the SAE World in Motion one, the first one with the glider, I would argue that although on surface it looks like it's an airplane, it fits in the science curriculum, I would argue that in an intermediate science or intermediate mathematics classroom that it would make a lot of sense to actually do this in a math classroom as an extension. So I'm a real fan of figuring out ways in which we can reinforce certain concepts repeatedly over a long time. We all know that students learn when they are provided opportunity to practice and revisit concepts. So to isolate a flight lesson just in science class for grade 6 doesn't necessarily mean that they'll remember over long term. So if there's an opportunity to go back and revisit flight, but through a different lens in math class, then you're also creating an opportunity for more deep learning in terms of science content, but also an opportunity to think about mathematics a little bit differently. So this glider challenge that SAE offers actually has the body such that it is ruled in sort of equal increments. You actually power the glider using an elastic band, which you would stretch to various lengths according to the ruled portion of the body. And there are ways of actually redesigning the wings as well as angles of release to actually collect some real-life data, right? So you would deal with sort of projectiles and be able to measure certain distances for different stretches of the elastic band. There's a variety of variables that you can actually control to collect some very rich data that can then be graphed and compared to. And in fact, the materials pretty much is basically like foam board. So even after the kit is used, you could reuse the bodies of the gliders to redesign sort of new versions of the glider. So I would really recommend that you think about not only in the frame of science where you might be doing STEM activities, but also how the science can be extended into other places like in mathematics. All right. So thank you for that. I think what we'll do is we'll go on to the next resource, which is the Physics Strand Focus for 9 to 12. So I know that some of you are primary teachers, so we're asking to sort of extend sort of your expertise or your perspectives on what it might look like in 9 to 12. And so for this one, what I thought we would do is take a look at something like the science fair. Science fairs have been traditionally in our schools. I remember doing science fair projects myself. I'm sure Dave remembers science fair projects himself.
I do.
And I'm thinking that maybe it's time that we sort of reimagine the science fair. So at the Canadian-wide National Science Fair this year in Montreal, there was a student there that actually came up with a new wheel. And he invented a new kind of wheel. So there's a link there sort of explaining what his design is, which to me it didn't resonate with me with what I pictured a science fair project to look like, so I thought I would share that link. And the other one is taking electrical circuits to the next level. What does it mean when we teach electricity in our classrooms, and what does that mean for today? So it's not, is it really about the light bulb? I guess is my question. So there are 2 links there. Take a look at that, and then what we're going to do together is brainstorm and create an engineering design experience for your own students, how they might actually reconnect to the science fair or rethink something that is relevant in our classrooms, like electrical circuits, and it has been for many years. So how do we reinvent that to be relevant for them today? So the link is along the side in the chat area again for you to take a look at, and then I've put up the brainstorming slide.
And Mally set a 5-minute timer. Thank you, Mally. Kia, they were just reading your comment and talking about what you said is actually entirely the engineering mindset that they have, that everything can still get an upgrade. You just think about technology, and because engineering is where technology and business really marry, and that is constantly on their mind is how can you innovate and reinvent the wheel with a little upgrade. Nice comment. Thank you.
Thank you for that. Made me chuckle. So I suppose we should be encouraging them to reinvent the wheel.
Once again, 90 seconds. And if you have thoughts on how to create an engineering design experience for your students, please add them in. It's almost like a Rube Goldberg suggestion, the random supplies and a task. And yeah, let them be creative.
Mm-hmm. Yes, Gloria, I do agree with you that I do love how the adaptive wheel came from a real life problem that was connected to a student making an observation about something around them. So I really like that part of the story. It's definitely a true engineering mindset.
Now the 5 minutes has passed, but we'll go on for probably another 30 seconds or so. We're still in the middle of typing and just getting some data in.
And Melissa, I see that I see your comment. You work for a company that focuses on STEM, and I see that you've offered some support for teachers in terms of robotics clubs. So I want to thank you for that, because I know that in working with our schools and our board, we are always looking for volunteers or resources to support. And recently I've actually been in touch with PEO as well as Engineers of Tomorrow with their Engineers in Residence program. And I know that they also recruit volunteers who are engineers locally, and they partner the engineers with schools. So I know that many of our schools in our board have shown some great interest in doing that. So I know it's really important to make those personal connections for our schools.
Very interesting suggestion about changing the classroom design to be more inclusive, particularly if the inference here is to use the students themselves to generate these ideas and get them involved in the process of making this kind of decision and evaluating it afterwards. So that no doubt they would come up with some frugal innovation, but also they would be invested into the outcome, which is a great way of really taking the inquiry method and bridging across to engineering, where engineering is so invested in the results of what they do and the reiteration process. So thank you very much for that. It's a brilliant suggestion. And I know that the standing workspaces has gone on in a few schools. I know I've heard that the TDSB is trying that. And there was Simcoe and Muskoka County District School Board, 1 or 2 classrooms I've heard of were doing the same thing, is the standing workspaces, particularly for the K-3 students. And they have found it has made quite a difference in both the behavior of the students and their ability to be focused and stay focused. So interesting suggestion. Thank you.
Yes, definitely. Go Eng Girl was mentioned as a camp. They also have Go Code Girl. Those are programs run by ONWE, so the Ontario Women in Engineering that I mentioned earlier. And actually, Go Eng Girl happens in many universities, all the universities that are part of ONWE. So if you're a school within a particular area, I would get in touch with the local post-secondary institution around you and see if they actually offer those programs. There is also a mention of Engineers Without Borders. Absolutely. There are a few organizations that will do work. In fact, the Engineers in Residence program is sort of being organized by Engineers Without Borders as well. The idea of inventing, that's sort of been the theme here. There is a program by the Learning Partnership called iCubed. iCubed stands for Investigate, Invent, Innovate. And if you're not familiar with that, you could Google it. And there is a full program for intermediate. So it's primarily for grade 7 and 8, but the premise of the resource actually I think applies everywhere. But I know that their program targets intermediate students, and basically it's a free program where students are asked to work in teams to invent something that solves an everyday problem that they identify, and they are asked to create sort of even a business plan. So it's kind of a different take on a science fair, and that is all free as well. So feel free to explore that resource. So I think we'll wrap up the session with some questions, and then we're also going to showcase some of the things that we can offer in terms of future resources, and support.
So I think we've answered the question, hopefully satisfactorily to you, of why STEM is so significant. And it's moving in now into Ontario and through the Toronto District School Board and Durham District School Board, and hopefully other boards are considering it as well. This is something that is worldwide. It is not certainly local to Ontario. And Canada now is just seeming to get on board the STEM bandwagon. So there's a lot of significance in terms of career opportunities and pathways, etc. The second question, goal, how do we support engineering and STEM? Hopefully we've given you some good ideas and some resources that you could leverage to use in the classroom and to help bring the really the glue for science, technology, and mathematics is that engineering mindset that puts them all into context. And the context really is for solving problems and coming up with innovation and solutions. So the engineering, although it's not explicitly in our K-12 curriculum, it's inherent in our inquiry approach to doing particularly science and technology, but also wrapping in the mathematics. So we are, by making that explicitly clear that a lot of things that we do in inquiry are really the engineering design process, and hopefully will help to sell to students that the engineering pathway is a very viable pathway, and we change some of the numbers of the data that Lisa was showing us earlier.
Mm-hmm. Also, there was a question earlier about the STEM process graphic. So I have emailed Melly a copy of a poster, a PDF of that. So I think Melly will be able to share that with everyone. Are there any questions at all?
Or if you want to speak, just put a hands up and we'll give you access to the microphone.
Feel free to put your hand up at any time. There's a few things that are coming up. Through OTF, Summer Institute, we will be offering a summer camp. It won't be Dave or I, but I promise you that James, Sarah, and Roberta are fabulous, and they will spend some time in July with any teachers who are interested to take a look at STEM and specifically physics in greater detail. The focus will be for grade 9 to 12 for that session. And then we do have an annual conference. This past conference was at Wilfrid Laurier University. We are a traveling conference, and that we are hosted at different post-secondary institutions each year. Next year we will be at York University at the Lausanne School of Engineering, and we're excited to be there because we will be focused on STEM. Again, during that session, the theme will still be finalized at that time. Our conference is always in May, and the final dates of that are still to be determined, and we welcome all K-12 teachers. We are a unique conference compared to STAO because we do have post-secondary participation, so you have a chance of seeing sort of and discussing and networking with educators in science, particularly in STEM and physics, from K to all the way up to post-secondary programs. So if you're interested in that, please connect with us. Our website is also on here, so there is you could become an OAPT member. The cost is only $20 per year, and we do have a newsletter. The newsletter offers sort of ongoing publications on instructional strategies as well as lesson ideas over the course of the school year. We do also archive all of our newsletters and postings, so you're more than welcome to visit the newsletter website to take a look at some of our archived newsletters. We have gone back and actually digitized all of our paper copies of our newsletters as well, including all of the demo ideas that we used to have a demo corner, and so there's a wealth of resources there if you're wanting to take a look at some of that. We also run a grade 11 physics contest, and it's hosted by the electrical and computer engineering faculty at U of T. So if you are a grade 11 physics teacher, and we recommend you sort of taking a look at that contest. So I think that's it for Dave and me. If you have some questions, we are more than happy to address any of them.
This is one closing comment, just to revisit something from a little bit earlier when Lisa was talking about Let's Talk Science and the data that we had from there. I would encourage you to go to Let's Talk Science on their, particularly K-8, on their resource website, because they have just a trove of wonderful resources that are all itemized for you from K-8, and they're free resources. So they've been made available through various funders, and they've been doing this for several years now. All you have to do is go on and register. They do need registration just because they need the numbers for the metrics to, again, just to justify to the funders to continue funding this project. But they have just a trove of wonderful resources from K to 8, and in particular from 9 to 12, they have a tremendous variety of STSE resources. So if you're looking to build that into your curriculum, then there's a good place to go and shop around.
And I do think that Let's Talk Science also has partnerships with post-secondary institutions. So if you're looking for a scientist to come into your classroom or an engineer to come into your classroom on a particular topic, they have been very flexible. I know that some of the teachers in my board have had Let's Talk Science, connected with Let's Talk Science, and had a guest come into their classroom to do a little session with their students, and had great feedback in terms of how the students connected with someone in the professional field. So I do know that there are opportunities like that as well.
A wealth of resources available for there. Yeah. You can see on the, there's a feedback survey that Mally has provided. So if you guys could go online and give us a little bit of feedback, OTF would appreciate it. Mally, do you have anything to say before we sign off?
Actually, I do have a couple things. Can you turn your mic off, please, Ty? Thanks. Yeah, I was just finding the Let's Talk Science link. I hope that's the correct one, so that we can also put that in the resources. So thanks, Dave and Lisa, for a great session, and I really like the way that you were able to cover K-12, and not a lot of people can do that. As Dave said, there's a feedback link on the page, and OTF would really appreciate if you could fill in, spend just a couple minutes filling in the feedback. There's 3 reasons for that. One is to provide Dave and Lisa with some feedback. The other is OTF would also like to know what you think about the learning and PD opportunities. And then, as Dave said, it's really important to share the information with the funder, who is the Ministry of Education. So there's 3 ways to get to the links. The first one is just by clicking on the link that's in the chat box. The second one is when you log out of this session, you will be taken directly to the feedback link, the feedback form, and that's probably the easiest way of doing it. And the third one is just I'm going to put the feedback link in the chat box, and you can click on that, and it'll take you to the feedback. There's just one more session coming up tomorrow, and then OTF Connects is finished for the season, and we'll start up again in October and look for registration in September. And as Dave said, there are lots of OTF opportunities coming up. The Summer Institutes, I think they called them camps. So the registration is now open for the Summer Institutes, and the physics one that Dave and Lisa described will be also will be listed there. And there's a technology conference coming up at the end of August. Registration is open already, and then that will be in Toronto. And finally, OTF also supports it looks like the deadline's today. So the Teacher Learning Co-op, the TLC program, and it's a great opportunity for you and your peers to get together in some professional development. So that's it. I'm just going to go back to the feedback survey so that you have that accessible. So thanks, Dave and Lisa, for a great session, and I think there's lots to think about. So thank you very much. And I just want to remind you that you will be getting a link to the recording and the resources that Dave and Lisa provided in an email tomorrow. So you didn't need to worry about jotting them down. They will be sent to you in an email, along with everything else that they added as they will be going. And Gloria, I'm going to add scientists in the schools, because definitely they are a fabulous resource for students. So I'll put that on the resource page as well. So thank you very much. And once you log out, it'll take you directly to the feedback form. So thank you very much for spending time with us. Yeah, so great timing, guys. You timed that really well.
Thank you. We were watching the clock.
Yeah, I bet.
We've learned to do that quite well. Dave and I are pointing at each other and looking at the screen.
No, that was good. That was really good. So, and it is hard to get people to participate because you certainly had, lots for them to think about.
I know, and we were trying to maximize what we provide as well, because we know that at this time of year, all they're looking for is a few tidbits to actually run with, right? So instead of and it's hard to tell from where we sit what primary and junior teachers might need. So.
Oh, so your high school, because those I thought those links were great. And I'm a junior. I was a junior teacher, so. And then primary before that, so definitely there was stuff there for them that they could actually do like tomorrow in the room, which is really what they want, right?
Exactly, and I think that's just because I'm at the